Welcome to Electronics Specify Insights, the podcast for electronics engineers. I'm your host, Paige Hookway. In today's episode, we're diving into one of the most exciting topics in the industry, Edge AI, the push to bring intelligent processing directly onto the devices around us rather than relying on the cloud. To unpack what this means, why it matters, and where it's headed, we're joined by two experts from Nordic Semiconductor. Oyvind Strom, Executive Vice President of the Short Range Business Unit, and Arjun Chandra, Head of AI, join me to discuss how Nordic is thinking about AI at the edge, the real-world challenges of deploying machine learning on resource-constrained devices, and what the landscape might look like as we head into 2026 and beyond. I hope you enjoy this episode. Let's get started. Hello everyone, and welcome back to Electronics Specify Insights. It's a pleasure to have you join us today. And it's also a pleasure today that I am joined by two people from Nordic Semiconductor. First is Oyvind Strom, who is Executive Vice President of the Short Range Business Unit, and Arjun Chandra, who is the Head of AI. So it's a pleasure to have you both here with us today. Why don't you start by just giving us a brief introduction to yourselves, who you are, and what you do? Oyvind, would you like to start first?
Yes, I can do that. So thank you, and thank you for having us here on this podcast today. So my name is Oyvind Strom. I'm the Executive Vice President of the Short Range Business Unit. So we are basically driving all of Nordic's Bluetooth and IoT products from this business unit, including our Edge AI strategy on these products. And with me, I brought Arjun. And Arjun, you can introduce yourself maybe.
Yes, thanks, Oyvind. So yes, I'm Arjun. I have an AI background. Been working in this field since 2003. And, I was in the UK for some time, actually, did my PhD there at the University of Birmingham, and then moving on to Norway 2011 through different research, engineering, and product roles, and now at Nordic, trying to drive various AI efforts here in the company.
Fantastic, thank you. And a lot of our listeners are definitely going to be familiar with Nordic Semiconductor, but perhaps one of you could just give a brief introduction to the company as well.
Yeah, I can do that. Nordic Semiconductor, we are the global leader on ultra-low power wireless connectivity. And these days, that also means from chip to cloud, where we deliver world-class hardware, the lowest power. We also have a very large software suite, so embedded software is an important part of our product offering. And also recently, after our Memfault acquisition, cloud services. So we can offer OTA, we can offer all kind of visibility and traceability of our software through this cloud platform.
Excellent, thank you. Well, now that the introductions are out the way, let's deep dive into our topic today, which is Edge AI. So firstly, how does Nordic define Edge AI within its product strategy?
So Edge AI, generally speaking, it means intelligence that lives on the device itself, right? But in our case, it really means intelligence that runs on a coin cell where the data is actually generated. No cloud round trip is required here. And we've actually focused really heavily on making it easy enough that any developer can build one without a PhD in data science. And really, we are bullish about democratizing ultra low power Edge AI. So that's pretty much what's driving the effort in the company.
Fantastic. And I guess following on from that, what would you say are the main drivers pushing AI at the edge today?
Well, there's a few core factors actually. So latency or speed, for example, decisions that are taken on device, they need to happen in milliseconds instead of seconds. It has to be really efficient, really fast. Privacy is a big concern. Your data should not leave the device when the decisions are made. Power is another factor. So local inference is radically more efficient than streaming everything to the cloud, for example. Then, of course, if there are billions of IoT devices that are all calling home to somewhere in the cloud, that's not really very practical, and also not something that is needed for the specific things that these devices need to do. Not everything needs an LLM, for example, right? And, at the same time, AI should really keep working even when connectivity drops. So that's those are the things that are pushing AI to the edge.
Yeah, excellent points. And I'm interested, we've been talking about Edge AI for a while, but how do you see Edge AI adoption evolving across industries in, say, the next few years?
Yeah, so we have seen Edge AI. It has been around for a little while, and that's maybe in a few years ago we could talk about being a technology searching for an application. But now we believe that Edge AI is really going mainstream. So we are moving from niche type of applications to mainstream, and we see where customers were trying to find what to use Edge AI for. Now they are planning their projects with Edge AI from the early days and from the start. And we see that within wearables, we see it in medical, industrial sensing, smart home, and audio, and many more type of applications. So we have seen models shrinking. Nordic, we bought Newton AI last year as well, where we have a very small inference models, and together with our NPU and accelerators, we have really a wide offering now on Edge AI technology, and we see our customers now start planning their applications as they out of the starting blocks for Edge AI, and that's really a shift in the market that has happened over the last year or so, I would say.
Let's focus on applications a little bit more then. So what applications do you see benefiting the most from Edge AI today, and why?
Yeah, so Oyvind already mentioned some areas actually. So really the applications that'll benefit the most are the ones that, of course, need to run on a coin cell and they need to not send data to the cloud. So things have to be very private. So wearables, for example, watching your heart, or medical devices catching anomalies in real time, factory sensors hearing, a bearing fail before it fails, smart homes that listen when you speak at them, actually listen. These are some of the applications. There are others as well, like asset trackers. So you want to track various things in your fleet as a logistics company. So there, we have a solution which provides both short and long range connectivity that allows for covering all that and more.
Yeah, I'm sure we could do a whole separate podcast on just applications alone. But I guess, before these applications are deployed in the real world, there's a lot of challenges that people need to overcome. So what are
Yeah.
you seeing some of the biggest technical challenges when deploying AI models on resource constrained devices?
Yeah, resource constrained is the word, actually. So every milliwatt counts. Models have to fit in kilobytes, if not gigabytes. And very, very critically, the people building these devices are actually embedded developers and not data scientists. So they have to be enabled. The tools that they are given have to meet them where they are. And, increasingly people are using Gen AI. So, we are sort of going there as well. So that's where it is. Ease of use and keeping models as small as possible, running as efficiently as possible. That's where the challenge lies. Yeah.
Fantastic. And following on from that then, what about how does Nordic approach the balance between compute, memory, and power budgets when enabling AI workloads at the edge?
Yeah, so I can talk a little bit about that because we put a lot of efforts into our product definitions and finding exactly that balance. Ultra low power is in the DNA of everything Nordic is doing, and we are really focusing on optimizing every little clock cycle in our systems to consume as little power as possible. So we have a large toolbox of things we can do here. Being in the latest and greatest process technology nodes with 22 nanometer embedded processes really helps us from a power consumption. So we have the option to integrate NPUs on our chips, and we do that with our Axon technology, which gives you up to 15 times faster inference on the CPU with a much better power efficiency than more generic NPU systems do. And then also with our Newton acquisition, we focus a lot on right-sized models. So having small ML models to solve, let me call it easy ML problems, but really data which is slow moving, captured from sensors, are typical use cases that we can do on our Newton models, and that only takes 5 kilobytes of code, and it's 10x smaller and much more faster than more conventional algorithms. So we have chosen an approach where we can either select very efficient software models, or we can do integration of power efficient NPUs, and that's kind of how we balance this from product to product.
Fantastic. And what about, we can't not talk about security in this conversation. So how does Nordic address security concerns around things like, model integrity, data privacy, or secure updates for AI-enabled devices?
Yeah. So, at Nordic, security isn't an afterthought. It's actually in the silicon. PSA certification, secure boot, hardware root of trust are part of the product. With Edge AI, we have already discussed a little bit. So the data stays on the device by default. Inference happens there. And, when you need to update a model, say a year from now, because that is something that machine learning products need to take care of, this model update would travel the same signed encrypted path the firmware does over secure firmware over the air updates based on technology that we have via Memfault and NRF Cloud.
Mm. And speaking of technology that you already have, how do low power wireless technologies such as Bluetooth LE or cellular IoT, how do they support new classes of AI enabled products?
Yeah, so actually they're two halves of the same idea. So, AI kind of decides, if I put it bluntly. So the radio kind of only wakes up when there's something worth saying. Let's just put it that way. So Bluetooth LE for what's near you, cellular and satellite for everything else. One chip that speaks to every ecosystem out there. That's how we see it.
Fantastic. And finally, a question I'm very excited to ask you is, how do you see Edge AI evolving in 2026, in this year?
Yeah, it's a good question, and we really see that ultra low power AI is on the edge is becoming mainstream. It's really the new baseline for both IoT and Bluetooth low energy applications, and it's not anymore a premium feature that customers are asking specifically for. As I said, customers are planning their applications today with Edge AI. It's not an afterthought in the project. So with new products out there, with a full portfolio of 22 nanometer projects, we are ready to onboard these customers with our NPUs on the nRF54 LM20B, where we set a new standard for on-chip intelligence, and together with tooling and our Edge AI lab, where you can build your model, we should have a very good starting point for our customers to take advantage of these new exciting technologies.
Fantastic to hear. I look forward to seeing where the year takes not just Edge AI, but Nordic as well. So before we wrap up, is there anything else either of you would like to add?
No, I think we are very happy to be here, and thank you for having us. And it was exciting to be able to tell about all of the new initiatives and technologies that we have here at Nordic Semiconductors.
No,
Very
thank you both
exciting
very
times.
much.
Yeah.
Yes, definitely. And I'm going to have to get you back next year to see how far Edge AI has progressed. So thank you very much for both taking the time to speak with me. It was a real pleasure, and enjoy the rest of your day.
Thank you.
Thank you very much.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.